The year is 2017, and I am freelancing and trying to make a little bit of money on the side. So my vertical as a freelancer was to come into an existing React and Node application, or React and .NET application. And now a lot of times these applications were put together by other freelancers, by other contractors, thrown together, but not quite in a way that it could be handed off to another engineering team. Or maybe the person in charge of it, a startup owner, organization owner, maybe they didn't quite have the money yet to bring in like a professional engineering team, so they needed someone cheap, like me. I was quite cheap in 2017. They needed someone like me to come in, help them refactor the application, help rebuild things so that it could be handed off to a more junior engineer. The goal was to take what was essentially a complicated mess and turn it into something that someone who you didn't need a lot of experience to understand what's going on with the application. And my job was to not only refactor the app to reach that point, but to help with the handoff. So the application that that I was on was a social media app. I'll just kind of quickly run through some of the user stories of this app, but it just really just to give you a sense of the context of what we were trying to solve. You don't really have to remember this. We had users attached to groups. We had users would be able to write to threads, your typical Reddit or Twitter kind of style. A big part of this was that there was going to be money in the system. So that was something that we had to care about a lot. It was authentication, making sure that we were handling data in a way that was very dependable, because we wanted, on this application, we want people to be able to raise funding among group members. And the key thing, first, a fast time to first interaction, which means we want people to be able to open up their phones and immediately, as soon as they open the app, to start typing stuff in instead of waiting 10 seconds before they could do anything. So there was quite a lot of responsibility for anybody who wanted to come onto this and do something impactful. The architecture, now it was up to me to build out most of the front end, as well as some of the servers. I don't know if I have a pointer, but I do have a pointer. So there was some existing .NET architecture for handling users. There was existing Ruby on Rails service. I don't even remember what that service was doing. Now my goal was to move everything over to JavaScript so that this organization didn't have to hire multiple developers. We wanted, they wanted just to be able to only have like 1 or 2 JavaScript people. So considering how we were passing information from either a phone or a computer to the server and back again was something that they wanted me to look at and figure out what the best solution for that was going to be. So how does that look? So going back to here, we have arrows going back and forth. We have the conversation between the phone and the server. What's going on when you're accessing a website, when you're accessing an application, trying to get a picture, what you're doing is making a request to somewhere in the world. So I have a tweet that has a photo in it. I want to, I'm clicking on this and I want the photo. Now there's a request. You're asking someone somewhere in the world to give me what I just asked for. That's something that we call the request. It could be anywhere, and this server could be anywhere, and I'm making a specific, I have what I'm asking for, my question that I want answered. I'll dig into this a little bit more, but this might be the typical shape of how the code will look in making this request. There is the most important item is what we would colloquially call the URL, the location of where I have that thing saved. If I have a cat picture saved on a server somewhere, I need to know the location of the cat picture and say where. And as a user, I have to say where it is, type it into the URL bar, click a link where it's already configured. Configuration, there might be special properties involved with asking for this cat picture. As the front-end developer, I might use a command something like fetch. This is where the magic happens, where I take all that information and I tell the browser to, hey, I tell the browser to package all that up and actually send some bytes out into the world. That happens with this special command right there. And we get the whole shape. I get my information back and I do something with it. I show you the cat picture. To get that cat picture, the server is making a response. They have to do something with the envelope that I've sent them so that they can send me an envelope back. This is typical shape of what you might be seeing. Different languages have different technologies to handle this. So I'm using Express here, but you'll see a similar pattern when it comes to using Django, when it comes to using Ruby on Rails. You have some sort of functionality to handle what's the URL coming in and where do I send that information to? Where do I send that request in the app to determine what I'm going to do with it? Hey, bud. So this represents the technology that I'm using. This represents the path. This could be anything. /API, /authentication, /cat pictures. And we do some business logic here to determine what I'm sending back. And I send that back out to the world, sending an envelope. And hopefully the way I described it makes it sound fairly simple. Make a request, send it back. And I keep saying those two words. It's fairly straightforward. But as the application increases in complexity, so too does your code. There's always that iron question that clients always have is how do we make it fast? And this is a problem that every part of the application is going to have bottlenecks. It's going to have issues that you're going to have to tackle. Requests per second on your server, how you render applications on your front end. With GraphQL, this is going to be a solution in figuring out that the request response cycle itself can be a bottleneck that we can hopefully resolve. Say you have multiple requests. Now this is starting to look kind of messy. If I'm authenticating somebody into your application, except for handling money, so we have to protect to make sure it's the right person. You're going to have to you're going to have to talk to the server then. You have to get the session information. If you have a bucket, so as I talked about in user stories, we had the concept of groups, but this could be anything. This could be, anything that's a bucket that holds other items. So a library that holds books. Tweets that holds individual tweets. A group that holds users. I have to get information about the bucket on the first run. And once I get that, I have to do something with it. I don't have the individual tweets yet. I sent them the bucket. Now I have information about the individual tweets. I might have to go back and for each individual one, make another request on the server to get all that information. If anybody, had done front-end development in the jQuery days, when jQuery was basically the thing, I would have to do this as a for loop. I make my initial request. There might be 100 individual items in the list, and I would have to do a for loop that grabs information from each of those individual items. Nowadays, we might have tools like Promise at all, but that is physically me going from your phone, or not me, but your code is sending information from your phone 100 different times to somewhere out in the world. And that's just for that one bucket. Maybe I need to grab posts. Maybe I'm looking at a user list. Maybe I'm doing whatever. A big common thing that you might see are analytics in applications. There's most people have 10, 20 different analytics trackers on their apps these days, and those are all making requests. Maybe 100. Maybe you got 100 Facebook trackers on your application. It becomes messy. Going back and forth like that. Crossing the world many times. What if our users in Australia and we're using AWS in Virginia? Now that's literally halfway across the world, 100 different times. we have the speed of light itself is a barrier. Now, a light can only travel around the world, what, 7 times in a second, I believe? I was a physics major, and I don't even remember. But yeah, there's only so many times that light can travel across the world. And if we're asking light to travel 100 times a second across the world, it's not going to do it in a second. This is the next problem. Come on. But just because we send a packet doesn't mean that the packet coming back is going to be optimized. It's not going to, it may not be the best possible packet that might want back. Essentially, so just the other day I was looking at Reddit's API. So you can build whatever you want using whatever threads, whatever posts are on there. And I was just taking a look, and I was like, if I were to create some sort of app that pulled in threads in a subreddit, what information do I get on a single request? So this is a single property, and this is all the information that I get on a single thread from Reddit. So that's this page and this page, and then there were like 3 or 4 more pages, but I figured I'd stick it to 3. I don't need all this just to render what threads are on there. And megabytes equal money. Like, how much are you paying on your data plans? All that code adds up. We want to try to have as few kilobytes going back and forth as possible. If you're not paying attention to the big trucks that you're sending all across the world, you're costing people money. And if you're not only costing people money, they might not even be able to load your app. When I'm not on Wi-Fi in New York, I have the 2nd best data coverage in the city, and there are still places where I'm not pulling that much information onto my phone because it's just too much and not enough because of these buildings here. So yeah, you have to care about what you're sending back and forth. Otherwise, that's going to impact the user. So this is the solution. GraphQL, it's a query language for your API. And what that means is this is adding a language on top of that request response cycle that I was talking about. If you look up GraphQL online, then you're going to see a lot. It's quite a big ecosystem. There's lots of technologies in the GraphQL ecosystem, but that's essentially what it comes down to. That conversation between your computer and your server. This is what that technology is trying to solve, what GraphQL is trying to solve. The goal is we have a bunch of requests going back and forth. We might have a bunch of servers, and what we want to do is take all those out and only talk once. Go back and forth just once between your server and your phone. Just a single request, and getting exactly what you need. So this is an example that I showed before. On the front end, what you have in your web page, you might have something like this. With GraphQL, we can bring it down to just that. We just literally just say what we want. Instead of 100 properties for the group, we're just grabbing on that first initial load. Maybe I just want these 4 items. I don't need 100 items to render when they first come onto the page. I only need 4 items, even if I have 100 items saved. After that, to make a vanilla GraphQL request, the bare minimum is make it what we call a post request. If you're not too familiar with like backend technology, it's just a type of envelope that you're sending and what's in it. You just stick it on, essentially put it in the envelope, that very first string that has your fields in it. You stick it in the envelope there, and then you send it on. There's only one endpoint. You might call it API, you might call it GraphQL. Only one endpoint, and then you send it out to the world. It's a new type of language. So it's simple. It does what we call simplifying complex state. So an application like Facebook, there's a lot of information that goes back and forth. There's a lot of information that someone's seeing. And it can get quite hairy trying to wrap an application around all that info. Now, GraphQL allows you just say what's there in the shape that you want. Shapes are something that we care about in GraphQL. How this data looks is what the data is. You don't have lines of code describing what this hero or the name or the friends are. You're just saying what it is, and that's your state. That is the description of your application. If any of you are familiar with statically typed languages, I know there was one Java person in the crowd, C#, items like that, TypeScript. You might recognize this sort of process with your own language because this maps very cleanly to a statically typed language. I declare the type of my my character name, and it's a string. In TypeScript, I call it a string. It's one-to-one mapping there. It eliminates the need for versioning, which is something I haven't really talked about. But if you're ever making updates to your application, you don't have to change your front end. You don't have to change how your UI is every time you make changes to your back end. Because all I care about is the shape of your data. As long as you don't change the shape of the data, you don't have to change the shape. You don't have to change anything in your UI. Something that I've done a lot is create endpoints that might say like API posts version 1. Version 1 posts, API version 1 posts, and then API version 2 posts. And then I have to go in, change everything over to version 2, 2.0, 2.1. Every time you change something in the back end, something in the front end has to change. And that's not good engineering. You don't want to have side effects like that. You want to, if you have to make a change, only make a change in one place instead of every place. And this helps with that. On the server, so this is an example that I showed before of what you might see on the back end. To give you an idea of how your code is going to change if you were to refactor over to GraphQL. If you have what we call the RESTful architecture, which is our traditional approach to building routing in the back end, where we map the types of your requests to how you set up your routes for those requests. You have, we write out business logic to create a user, get a user, get multiple users, update them, delete them, do whatever. And then we write individual routes that says every time we're doing a get request, get a user. Every time we're making a patch request, update the user. We're writing code multiple times imperatively over the type of request that we're making. There's like, how many, traditionally we only use like 4 or 5 different verbs, but there could be like, I think there's like 100 different verbs technically in the spec. There's like a whole ton. And if you want to use them all, you're imperatively having to do that individually. But if we were to switch to GraphQL, the concept changes. So going from controllers to resolvers. Hey. The idea of the resolver is you're still going to have to write business logic because your data is stored in a database somewhere, and you're always going to have to write some sort of code to handle how you're pulling information from the server. So you're never going to get rid of this top part here. Yeah, you're never going to get rid of this top part with the controllers. We call them something slightly different. But what we are changing is, one, we configure whatever technology that we're using. So, Express, I'm using Express library. If I'm using Java, I'm going to use a Java library. I have my schema, as I said before, which is where I'm just saying what the data is. And at the end, I just have a single endpoint. So beforehand, if I had business logic for 50 different types of information that I might want, I would have to write 50 different endpoints. But in GraphQL, I only have a single one, and 50 pieces of functionality. On top of that, so when it comes to the schema, so I showed resolvers, and one of the key benefits that I feel, especially since I know a lot of people here are either fans of TypeScript or want to get into TypeScript, so I wanted to kind of point this out specifically when it came to dealing with schemas. This is the request I said before. This is what you're writing on the front end, where you're just saying what the information is that you want. On the back end, you're just writing that. You're taking the information that you have, and you're just typing it. You're adding a static type, saying what it is, whether something's a string, whether something's a number, maybe it's an array. of other things. It's clear one-to-one mapping, and if you add a TypeScript on top of that, it's all the same properties, and you're just using TypeScript typing or whatever interface that you created for that. There are libraries that allow you to only write all of this once and automatically exports all three types of things that you want. So you just, I feel like people should just kind of write their own library to do this, write your own code to export your TypeScript types, but it simplifies things quite a lot. This isn't something you can really get out of the traditional architecture of REST or how we have been doing programming for a good 20 or 30 years. By GraphQL, as I said, you get that type safety. Instead of, one thing that I neglected to talk about is that with REST, most of the data that you have coming in is in a string. So that's something that can add complexity when you're trying to figure out on the front end. When I'm getting a string of stuff back in, what's actually a number, what's actually an object, what's actually an array. There's that layer of understanding that you have to add on to that. GraphQL automatically tells you what that is, what that exists as. You get exactly what you need. As I said, if there's 100 properties and I say I only want 4 of them, you only get 4 out of them. You can get many resources in a single request. If I have authentication in one place, if I have users in another place, groups in another place, I'm still making one request, and I can pluck things out of multiple buckets, all just with a single question. And most of all, one thing I like is that there's a big ecosystem for it. Now, there are a lot of tools to make this easier. When you're dealing with a new I don't want to call it like a programming language, but it's a query language. Now, there is complexity up front in trying to figure out those concepts. I don't want to stand up here and say that this is an easy thing to learn when you're using GraphQL for the first time. It can be quite tough, trying to grok the different aspects of it and setting it up. But you have a number of technologies that does make your life easier. In React, we have something called Apollo, which allows you to do that initial request that I said back then about how you set up your post method, how you put it into query body. Apollo React is going to do that for you. It gives you a number of components that handles all that under the hood. Apollo also has its own server, and you don't have to really go through all this. This is the kind of thing you want to go through on your own. But this allows you, just using Node.js, you don't have to worry about how GraphQL plays with Express by itself. You can just use Apollo, and Apollo will handle all that under the hood. You have something called Graphical, which allows you to visualize your data. So I can set up my server to show all the data that's available and to make mock queries against it, so that you don't have to keep bothering your team to figure out what data do I have available. I can do my own mock request to figure out what do I need on the front end. Graphical is either, it's a good tool for that. And there's a number of case studies by different companies that use GraphQL today. Facebook is the company that came up with GraphQL in the first place, and they're the first ones that use it live. And they're the ones who showed why you'd want something like this. But feel free to check out what these other companies have written about, and get a sense of how it helps solve their problems. And that's my high-level overview. Instead of a Q&A, I'm not a big fan of Q&As because usually the speaker just gets up and dodges anything after the first 2 questions. I kind of just wanted to open it up to people, and if you've used GraphQL before, raise your hand and just talk about it. If you have any questions, feel free to talk about it. If you just have any opinions about anything that I've said, I haven't gone in depth on quite a lot. I haven't gone in depth on, but if there's anything you want to know more about, just head up and talk, and open discussion. Say what you want. You can even come up here and just grandstand me, just give another half-hour talk about everything that I've just done, but better.
That's what I was planning.
Exactly. And yeah, my slides, my social media, and I just have that link there in case you want to look at it. Any thoughts?
So let's say you have a client UI and a server, and you're implementing GraphQL. The GraphQL is essentially like middleware at that point, and it's like used to, by the client to query things that are on the server. Is that like a correct understanding?
Yes, when it really depends on how you want to implement it. So the standard tools right now sets it up as middleware. So that panel that I had way back when. Yeah. No, actually, even further back, it's set up so that it's a middleware node. You can always just roll your own GraphQL approach to it and just set up a standard route as a standard route. It really just, you need a way to take that query language, because it's really just a string that says what you want, and convert that into actual routing. And the tooling that's at the ecosystem right now has set up middleware so that it handles that for you. But you don't have to use any of these tools. You can set up so it's not middleware, that you're just handling that string yourself. I don't know if that really kind of answers what you're going for.
So now Apollo essentially replaces Redux as your state management system? Is that how it works?
Yes. Which might be troublesome for some teams. I actually, and this totally was not a queue up by him, I actually wrote my own library to resolve that issue. So if you already have a Redux architecture and you want to migrate to Apollo's approach to handling state, I have a library in GitHub that, I don't know if it works very well, but you can look at the code and see, get your own ideas of how you can migrate from one to the other. So Apollo does have its own way. Apollo does have something that replaces Redux. And generally you don't want to have two single sources of truth in the same application. But there are ways to resolve moving from one way to the other by using some sort of bridge technology to keep them in sync while you're migrating from one to the other. But you don't have to use Apollo. As I showed way back when, GraphQL is really just sending us, like this is the core of GraphQL. You say what your fields are that you want. You say that it's a post request. Technically, you can make it a GET request if you're not doing any mutations, but stick with post requests, and you just stick it on a property called query. And most server implementations of GraphQL will recognize this. Apollo really just adds some syntactic sugar over something doing this.
Apollo, it used to use Redux originally with Apollo 1, and then in Apollo 2 they split it up into a lot of different components. There's like link and HTTP, there's like 10 of them. But they basically are just using a context API. So they found that way it was a little bit not as restrictive of using the Redux if that wasn't what you wanted to use.
And then they refused well, on top of that, like he's right, but they refused to deal with the use case where people were already on Redux, which was one of my complaints. I was one of the complainers when they first released version 2, was that they didn't deal with that use case. Apollo 1 allowed you to migrate from Redux fully over to Apollo because it was already using it under the hood. But version 2, they kind of smacked us down. They were like, well, you shouldn't be using Redux. And not like, but what if we're already using Redux and we want to use your technology? What do you do?
Can replace it, but it is a lot of setup to try to use Redux with Apollo now.
Which is why I made my own library to make my life easier. And then I released it, and it only works for my use case and nobody else's. Which is why it's only a 50-50 chance that it'll work for you. But you can at least look at the code and see what will work for your use case.
So you still have like traditional REST endpoints? You have your, like the REST methods aren't going away, like get and post, put, you can still use those that REST terminology, but now
on GraphQL they use mutations in queries. So if you go to graphical, do you have it live with the graphical?
Yeah, I don't have it live.
Okay, on graphical, if you all the way to the right, or if you go to that screen, over on the right, there'll be like a slide out that'll literally have like every one of the endpoints for the queries and for the mutations, but it's not specifically like getting posts as you're thinking of in a REST API. They consider them mutations, or if you're updating and changing something in query, we just grab information. So I guess you can look at that as getting posts, but that's about the extent.
And on top of that, you can have both in the same application.
Yeah.
Your GraphQL is going to be on a single route. There might be things that you still want to split out into their own routes. You know, maybe you have a specialized way to handle authentication. That could be its own route, and you can use your traditional REST architecture. But for anything else, use GraphQL. They can easily live side by side together on the server. I feel like it's easier for them to live side by side on the server than it is on the front end.
I have an application where the way I split it up is I have GraphQL running on a 4000 port, and all my REST APIs for like if I'm working with like a third party, like I'm working with SendGrid or MailChimp or anything else, then I'll still use my typical get REST APIs, and I have that on like a 3000 port. So they can work in the same architecture. You just have them kind of pointing to a different set.
And a good example of a company that's doing exactly that is GitHub. They have a REST, they have a number of REST APIs, and they have a GraphQL API. And you can choose to use one or the other, depending on what you want. They try to push people to the GraphQL API because that's what they're actively maintaining, but the older ones are available in case that's just what you would prefer. But I mean, that approach is more work because now you're maintaining two different styles. But that's something you might want to care about when you're migrating from one to the other. When it comes to new technology, as much as people want to, never, ever, ever just 100% hop on a whole hog in a big refactoring plan. Always go one piece at a time from one technology to the other. Otherwise, you're just causing many problems for yourself. And technologies that allow you to migrate easily, I feel like are the stronger technologies. If it requires you to make a jump from A to B 100% in one clip, I don't think it's a good tech. Now, was this useful for anybody? Like, do you have anybody just have any opinions or thoughts on like how, I don't know, anything here? So this is, I want to, open discussions are a little bit different. I don't like Q&As. They're never really useful for everybody.
I thought it was a good presentation and a good high overview. I can follow along when we're discussing.
Cool. Thanks.
I have a question.
Yep.
You said that Facebook was the first to use GraphQL.
They invented it.
Great.
How did it become sort of common practice? Is it something that they released, like they started using it and then they found it to be?
The history behind it, Facebook was trying to find, like you were saying, when you were trying to get like data with a RESTful API, you would get this massive amount of data, and the only thing you needed was like a URL, like an image or like a title. So if you want, it was mostly for mobile applications in the beginning for GraphQL. So if you're on a cell phone and you have limited data, I don't want to download 3 megabytes every time I go to your application. So Facebook was trying to find a way where they could specifically say, this is the data that I want. And all I want to do is send this guy a title, the name, image, URL to some image, and that's all I get. So instead of getting 3 megabytes, I'm sending 15, 20 bytes. So it was a lot smaller from that point. So after they perfected it on there and Facebook said, you know what, I think a lot of people might want to use this. So let's just kind of open source it. And they just let everybody start to use it.
You open source it, and I think there's also that sort of cynical view that the reason why it got so popular is because Facebook open sourced it.
Absolutely.
If Random Series A startup came up with GraphQL, would we be using it now? It was because it was one of the big ones that basically just dropped it and said, this is better than the other thing, guys. You should try it. Everybody kind of hopped on that.
Does the same go for Apollo? Like, is that something that Facebook developed?
Apollo was created by Meteor. Facebook has their own thing called Relay. Relay, if you look into it, the learning curve is crazy. Like the markup for it, Relay is a lot more efficient, like it's a smaller footprint, and it's actually faster than Apollo. It's just, take a look at it, you'll see why everyone goes to Apollo. And they know that, so the next release of Relay is supposed to be similar in structure to what Apollo's doing, because no one's adopting Relay because the learning curve is just out of control. But have you heard of Meteor?
I haven't.
Oh, okay, Meteor was like, it was like a hybrid of a front-end, back-end type architecture in JavaScript.
Yeah,
That
kind
company,
of felt like, sort of like akin to like JavaScript's version of
Yeah.
Rails essentially.
Okay.
but they're the ones who created Apollo and they open source it, and everyone kind of was doing GraphQL from Facebook, and they were, a lot of people like I use Apollo, so a lot of people migrated to Apollo too. Just, those were the two, he had a list of a lot of GraphQL different architectures, but everyone's using Apollo or Relay, those are like the two main ones.
Yeah.
And they only use
complain
Relay
about
because Facebook made it.
Yeah, I remember back in the day, because I was following GraphQL, essentially from the beginning, because it sounds super interesting, and a lot of people loved the idea of GraphQL and tried it out, and then they tried Relay when that came out, and there were a lot of complaints, and yeah, Facebook popularized the idea of GraphQL, and it convinced everybody, but Relay kind of forced people to try different items.
Yeah, Relay.
Yeah. So at least Facebook doesn't completely dominate. I think Apollo just got bought by somebody now, didn't they?
Maybe.
Oh no, they didn't get bought. They got a whole bunch of funding. They got like a very high amount of funding. And they just went through a series and they just got a whole shit ton of money to build new stuff. So we might be seeing more from Apollo over the next year or two.
Another thing Apollo did that I find interesting if you want to do like more like real-time architecture is they just recently released subscriptions. So now you can actually, instead of trying to poll all of your request responses, you can actually use a subscription to actually push that into your app. So that was another thing that Apollo actually just did recently that helps a lot.
Yep, and subscriptions, you use it just like our query mutation.
Right,
You just
exactly.
declare what you want, you just say it's a subscription, and it wraps over your WebSocket. So you don't have to worry too much about the implementation of WebSocket. Yeah, you don't have to worry too much about the implementation, you just say what you want, and it's going to remain real time.
Yeah, because outside of using these subscriptions, if you ever made like a mutation and you changed something on your database, the only way your app would know that anything changed is you have to do a refetch, and then you have to call that get a query to get the data back. So it wasn't real time. It was quick, but you still have to make another call to do that instead of the server saying, "Oh, something changed. Let me send the data back automatically."
Well, I mean, you would get the result of the data, right?
Yeah.
Just like it's like a traditional like response or request. But if there are any side effects
Right.
in the mutation, you wouldn't know until the next time around.
Is there like a convention for the CRUD operations for like GraphQL? So like obviously HTTP has that enforced by methods. So like what is that implementation for like CRUD operation from the client side?
If this answers your question, I would say that the idea of the query mutation and a subscription is
Yeah.
only really just those three types of requests. Everything falls into one of those buckets. The query is your traditional get. You're just getting information. Mutation is changing data, and that maps to put,
Patch
post,
everything, yeah.
everything deletes. So it just kind of, yeah. So
Yeah, the mutation is more like the all-encompassing.
Mhm.
If you're changing anything on the server itself or the DB, then you use mutation. If you're just grabbing data, you just run it.
yeah, the idea is the ones remain declarative. So the more you get into using HTTP verbs, the more imperative that you're being. You have to, you don't really care how the user gets their tweets back. The user doesn't care if it was a post request or a put request or a patch request. They just want the data. The idea of GraphQL is that you just talk about the data that you want, and you just kind of leave the lower level ideas about the HTTP verb, just to the framework. Just as I said before, everything is basically just a post request.
Gotcha.
Because it doesn't really matter.
Okay.
Because all you really care about is that requester. But it doesn't have to be a post request. That just sort of like, it would be odd if it was like something like a put or a patch.
So But it almost seems like it's still piggybacking like HTTP. Should it just kind of be its own convention and like implementation of web technologies?
It's its own abstraction on top of it. So, like the idea of the HTTP verb is fundamentally how the web works. But when we're writing routes, that's not what we do with those verbs is really just making a one-to-one mapping of how the web works.
Yeah.
So, but we don't really need to do that. Like we don't have to have that one-to-one. Now, our request comes in with a specific verb, and then we're writing a route that matches that verb.
Yeah.
So it's really, you're never going to get rid of the idea of the post or the get, because that is how HTTP itself works, unless we replace that. But we don't have to use that abstraction in writing our code. GraphQL gets trouble. If that makes sense, I don't know if that makes sense.
No, I mean, like, I get it, like,
Yeah.
but like HTTP is all kind of built on top of RESTful design, which was supposed to help, like, you know, publishing your static like endpoints in JavaScript. So that convention helps create, you know, a better understanding for designing for other applications, because there is this.
I would even say it's more the other way around. RESTful is abstraction over HTTP.
Okay, yeah.
But yeah, and like I said before, there is some extra like knowledge that you have to know to be able to work with GraphQL. So, for me, it was very difficult understanding GraphQL in the beginning. I had especially in the beginning, there weren't really people that knew how to really talk about it at that high level. So there is going to be that initial painful step in figuring out how to go from what you're used to how this works. But once you get past that initial hurdle, it really does optimize things. I don't want to say it makes things easier or make things better. It makes that cycle of request and response more optimized for what your use case would be after. Yeah, everybody seems to be running low then. Hopefully this was useful. I'll have a watch. Okay. Not too bad. About 45 minutes, which was aiming for. I think I might have been talking a little bit too fast, because I would expect.
Thank you, Denny.
You're welcome.